Good afternoon, everyone here. First of all, I'm really glad that you stuck around here with us, despite the weather, the storms, whatever was going on. I'm going to speak a bit about blockchain in the enterprise IT context. So I want to maybe dispel a bit some of the myths that we hear around blockchain. So I'm Max Mortillaro. I'm one of the co-organizers of TECHunplugged. I've been going to several events, so technical delegate, expert, blah, blah, blah. This is my blog. This is our company website, TECHunplugged. And this is my Twitter handle. And this is my not so pretty face. Sorry. Right, so we're going to talk about some things, but we're also not going to talk about certain things. So while we're going to talk about blockchains in general, we're not going to talk about Bitcoin, cryptocurrencies, investment advices, mining, artificial intelligence, or the lack thereof, singularity, etc., etc. So, blockchains, that's my face when I hear somebody saying, let's use a blockchain. I think that blockchains are pretty cool to have a real use case, but we tend to see, especially in the last year, those of you who are following blockchain and what's going on in this space, you've probably seen that there's pretty much a company launching a blockchain project or a token or whatever for pretty much everything, right? So we're almost at the point where we're going to have a blockchain token for blockchains almost. So I just want to here take a bit of a step back and explain some of the concepts that we see, some of the things which are somewhat fundamental to understand blockchains. Some of the attributes, concept is not a good word to put it up, but these are some of the things I see which are somewhat relevant with blockchains. So one of the first things with blockchains is that it's a chain of blocks. Yeah, it's not really smart maybe for me to say that, but it's a chain of blocks which are all tied one with the other. And in the blockchain, we'll talk about that later, one of the main concepts or ideas is that you're in an environment where you do not trust the actors which are taking part of the blockchain, which can be a couple actors or can be more actors. And for that reason, because you do not trust the persons, you need to have some data integrity, and you need to have a way to validate the integrity of the data in a way which is irrefutable. So for that, mathematic formulas are being used, so hashes or cryptographic elliptic curves are being used. Don't want to go too deep into the details around that, but just to explain that you want to have some kind of mathematical integrity or proof of integrity to make sure that the data is valid. One of the other concepts of a blockchain is the concept of disintermediation. So if you have an intermediary or a trusted third party, you probably don't need to have a blockchain because you have an entity that you trust, and therefore because you and all the other parties trust this third party, this higher third party, then you probably don't need a blockchain. If you trust the banking system, then you just need to send money through a bank to someone else. The money is going to be sent to whatever central bank. There's going to be a settlement between your bank and the bank of the other person, and that person is going to receive the money. So you don't need to have a blockchain in that case because you have an intermediary that you trust. So the concept of the blockchain is to disintermediate, to get rid of the intermediaries, and to have just this ledger which is between you and the other parties you interact with. One of the other concepts you have is a transactional dependency. So that means that your transactions, or whatever it is, if it is a money transfer, if it is tracking a shipment or whatever else, you want to make sure that the data which you are tracking here is trustable from the beginning. Some companies are using blockchains, for example, to track diamonds, to make sure if the diamonds are clean or if they're not clean, if they come from war areas or not. Well, in that case, the first thing of all is that you need to trust the first person which inputs the diamond. You need to trust that person to know if it's true. But whether this is true or not, what happens is that you will have a chain of activities which go around the kind of trustability of this diamond. It could be dairy products, it could be whatever food, you want to trace it, and you need to make sure that there's a clear tracking of all of that. Then you have another concept is whether the blockchain is going to be public or private. If you have many actors which do not know each other and who do not trust themselves, then a public blockchain is probably going to be the best use case. If you do not trust the actors, but you don't need to interact with the general public, if it's just a kind of B2B system between some companies, then the blockchain could be private. And then the last thing you have here is whether you have a permissioned or permissionless blockchain. A permissionless blockchain is a ledger where everybody has writing rights. Writing rights. I say that bad because I'm French, so I don't try to say it, but this is W like rights. Writing permissions, okay? So if, as I was saying, if it's permissionless, you want these to be available for the majority of people, and you want these people to be able to write to the blockchain regardless if you know them or not. If it's permissioned, then in the case of a permission blockchain, it's a blockchain where certain of the actors or all of the actors have either equal permissions to write or different permissions to write. Somebody will be able to see some of the transactions, somebody will be able to write transactions, somebody will just be able to read them, and so on. So these are some of the main concepts here around the blockchains. This is a very simple decision diagram about whether you need a blockchain. The most likely case is that you won't need a blockchain, and I'm going to move on that later on. But you might have real use cases. This is the funny one, we'll get to the real one later. I think that trust is really the kind of decisive factor in deciding whether a blockchain makes sense or not. Because if you're in an environment where you trust everyone, you don't need to go to great lengths to implement a technology which has very specific requirements. Requirements in terms of computational power, requirements or constraints in the way the data is being stored. So we're going to see right after this slide a little diagram which is going to be a bit more explanatory. I'm really sorry for the color set, but we've been crazy busy here with organizing the event and making sure that everybody makes it to the event, so I don't have a chance to make it a bit more legible. What you're going to see here are some of the lines. I don't know if you see them properly on the screen or if you have some issues with the lighting here, but anyways, one of the first ideas or concepts about a blockchain is to store state. The state can be the state of a transaction, it can be the state of whatever activity which is going on. If you do not need to store state, you probably are good off with a database. You probably don't need to implement a blockchain to store state, if you don't need to store state. The next hop here is whether you have multiple parties which are interacting with you in whatever you're doing, whatever your business is. If you don't have multiple parties, if you don't need to store state, or if you need to store it but you're a single party, you don't need a kind of blockchain or ledger which is going to act as a central authority whatsoever. You're the only one here, you're the king in the castle, you don't need anyone else to validate what you're saying. It's like if you talk to yourself in the mirror, you're probably going to listen and agree with what you're saying. So it's the same here. You don't need anyone to validate what you say, and you're good off with a database again. The third thing is whether you are going to have a trusted intermediary or not. If you are multiple parties and you have a trusted intermediary, like I was saying before, it can be a central authority for the banking system, it can be an authority for settlements between, I don't know, insurance companies, or if you have someone like a shipping company which takes care of contracts or whatever. It can be pretty much everything. As soon as you have a third party which intermediates with all of the actors, and this party is trusted by everyone, then you don't need a blockchain because everybody trusts each other. So in the case of a trusted intermediary, we're off again to a database. Now we're jumping to the next one. Do we know the actors? Do we know with whom we're interacting? It could be people we know, it could be our brother-in-law, it could be a friend, it could be someone we know from work. And with these people, you already get to a certain level of trust. But there are also friends or people you know that you do not trust. So with these people, if they're going to tell you, yeah, just send me $500, if you trust them, you're going to send them $500. But if you don't trust them, you're likely not going to send them any money, and you're going to have some warranties or something like that. And it works in a similar way. So if you know the actors and you trust them, you don't need to go to the extent of implementing a blockchain. You will probably be off with a database, and you should be good. However, if you don't know the actors, you're probably off to a public blockchain because many people which do not know each other will need to be interacting together. If you know them and don't trust them, then you can either go for a public permission database or a public permission blockchain, sorry for that, or a private permission blockchain. The key here is whether you want to have public visibility over the transactions. If you don't need that, if you're in a kind of B2B chain of whatever suppliers, manufacturing companies, which are all interacting with the other, you could probably be good with that. I mean, nobody needs to know about what you're doing. Probably neither me or most of you in the room wouldn't be interested to know whether a shipping company has been sending some containers to another company, right? So that would be the main thing. So regarding this decision diagram, do you have any questions? Does it make sense to you so far, or do you have any questions?
So besides cryptocurrency, what's a potentially practical use case?
I'm going to come back to that. I'm going to be that guy who says we're going to talk about it in the next slide. I always make fun of that when I'm at presentation and briefings, but today I'm the guy who says we're going to see that in the next slides.
I had a question.
Yeah.
You're talking about blockchain. There is somebody who talks about Tangle. The other part of technology called Tangle, IOTA. So how is that different from blockchain?
Which technology you said?
Tangle.
I haven't heard about that actually. So that's something I have to Google once I get back to the hotel. But thank you so much. Hopefully I'll figure out something good today. Thank you. Okay. But can you maybe are you able to explain in a short sentence what it is about, or do you think I should rather Google that?
I did talk to you.
Oh, yeah. Okay. Good. Very good. So here I wanted to explain a bit some of the difference between the database and the blockchain from a couple attributes. Of course, there are many more attributes than that, and I need to make everything fit into 25 minutes, so I've got slightly less than 10 minutes maybe to talk about that. But just some of the attributes between the DB, a permission blockchain, and a permissionless blockchain. Again, because I'm a left-handed guy, I started from the bottom up. Sorry for that. So a database, in the database you have a central management, and you don't need to have any kind of decentralization. The decentralization is the concept that the data needs to be existing in multiple places so that its integrity cannot be attacked in a certain way. That's one of the concepts. It's not the only concept, but the more distributed copies you have of the data, the less you're prone to attacking the data, compromising it, destroying it, whatsoever. So with a database, what you're going to see is that you're going to have a very low latency. It's then dependent on physical factors such as the storage, the compute you use, the kind of computers. But generally, a database will be a low latency mechanism. You will have very high throughput, and you don't have any validation mechanism because you're trusting the data you're writing, and thus you don't need to validate the data that you're writing. You just send the data, you write it, you get an acknowledgement that the data has been written, and you're done. In a permission blockchain, you have this amount of decentralization because it is a blockchain, and therefore all of the participating entities should maintain a copy of the blockchain. Of course, if we're talking about a permissionless blockchain, which we see in cryptocurrencies, the decentralization is very massive because you have a lot of nodes all around the world. But if you're on a permission blockchain, which is going to be typically between several companies or several entities, but not something which is global, then you're going to have a certain level of decentralization, but not as huge as in a permissionless blockchain. So with a permission blockchain, you're going to have a medium latency and high throughput. The reason it's looking slightly, it's not looking as good as a database, it's not as bad as a permission blockchain, but the reason is that in a permission blockchain, even if you don't trust all of the actors, you don't need to do very intensive computing about validating the data which is written, because it is permission. So it means that you, to a certain level, you do trust the persons. You do not trust them fully, but you trust them to the level that you have granted them some rights. So you've granted them the ability to write a certain kind of operations, but not another kind of operations. Let's use a banking system as a kind of concept. You're working, for example, in treasury and trading, so trading at the NASDAQ or whatever, and you have someone who's a junior in the job. You're giving the permission to trade up to a certain amount of money, but not up to, I don't know, $500 million or whatever. So here the permission is pretty much the same concept. You allow some of the actors a certain level of activity, but not a full set of activities. It's pretty much up to you, pretty much up to the project you're deploying, to the blockchain you're deploying, and so on. In that case, the validation mechanism, because you need to validate the rights, because it is decentralized, and thus you have many nodes. I wouldn't say you have 1 billion nodes or 1,000 nodes, but you will have 50, 20, 30 nodes. It is the same concept as distributed computing. So here we're going to make a break and talk about what is a Byzantine fault and what is Byzantine fault tolerance. A Byzantine fault is a condition where two different systems see, let's say, a different result, but all of them mark the result as valid. So an example is the Pentium fault we had on old Pentium processors, which were unable to make floating point calculations. So you were making a division, and one of the processors without the fault will give a valid result. So you will do the division, and you will get a valid number. And the computer will report that this number is valid. On a faulty Pentium processor, you will do the same calculation, the same division, and you will get a faulty number, and yet the processor will return that the result is valid. There's a really interesting website of the NASA which is reporting about Byzantine fault conditions which they had in several space missions, and many close calls they had where a Byzantine fault could have caused catastrophic failures. There's a really, I don't know, we have 40, 50 study cases. So a Byzantine fault will be a case where a certain amount of the nodes in a permission blockchain are going to report a transaction as valid and another number as invalid. And here, the Byzantine fault tolerance mechanism is a mechanism, and I'm not going to plunge into that, but it's one of the resolution mechanisms which helps determine which nodes have the right answer somehow. You can Google Byzantine fault and Byzantine fault tolerance, it's quite interesting as well. So this mechanism is kind of requiring some CPU calculation as well. It needs some validation, a mechanism in place between the nodes to determine which are wrong, which are right. But still, it's something that is not as consuming, as CPU intensive as a permissionless blockchain. In a permissionless blockchain, I would say the best example you can see around, sorry, it's Bitcoin. And you have totally decentralized infrastructure. You have a very high latency and a low throughput, and even on the low throughput, you can talk about the size of the blocks in the blockchain, because you can store only a certain amount of data. Of course, it's not something which is fixed for life, it's arbitrary, depends on the project. But what is important in a permissionless blockchain is because you trust absolutely no one, you need to have an irrefutable proof that the data is valid. And the way it's done is through intensive computations, which are done through nowadays ASIC chips or GPUs and so on. And those computations take some time to happen. These blocks are really, there's a difficulty level which is kind of encoded in the algorithm or whatever. But to validate a block, to validate a write, you need to make sure that a block has been found, or that you use a consensus mechanism as proof of stake, which is you own something in the blockchain and you do an election mechanism. But I think the most, I would say, emblematic one is proof of work. You need to throw a lot of computing power to validate that the write you are doing is actually a valid result. So because you do all these computations, you have to wait, and thus you have a very high latency, and thus the throughput is low. And when you compare these to that, you can see that you have to not just look at the fact that blockchain is cool, but the fact that you may have some imperatives on your application side which tell you that perhaps a database is not as sexy as using a blockchain, but it's maybe the best choice. So I've put here some of the use cases that we can see. Of course, bear in mind that some of the use cases which are here are nothing really new, because you have supply chain management systems which work perfectly as of now without a blockchain. You have interbank payment systems and settlements who work very fine without a blockchain, and so on. I think that we may see in the future an adoption of blockchain for the first two use cases, supply chain management, interbank payments, and settlements. But I think that most of the finance industry, and as well as the supply chain industry, are still kind of exploring options and determining if these solutions are performance is not a good word I heard. So if they are fast enough, if they are, let's say, if they provide a sufficient throughput of transactions to go through. One of the things which is often compared by people which are looking to the cryptocurrency space and which are talking about disadvantages of blockchains, they are often talking about the amount of transaction, the throughput, which is very low, around, I don't remember how many transactions it is per second, but we're in the hundreds or the thousands of transactions probably, compared to the 500,000 transactions per second for the Visa cards, for example, for credit cards. So there needs to be some more research to be done on how to, let's say, improve the fluidity of the transactional processing in blockchains. Of course, what we were talking about right now were typical blockchains where you have a series of blocks which go each one after the other. I don't want to go too technical here, but blockchains, usually like Bitcoin and other things that we see around, are using a Merkle tree structure, which is a block with a hash which is referring to a parent, and so on and so on. What we're seeing now is a thing called a direct acyclic graph, where there is a kind of indirect parent-child relationship, which is not like going one to one to one to one, but you can be the parent, you can be the child of a parent which is here, and so on, and you don't need to have this direct relation. But and diverging. Use cases which can be interesting are proof of ownership. You can use that for a patent system, for example. You can input your data into a blockchain and make sure that your patent is protected over there. You can use that for notary services. You can use that even for some escrow services eventually. One thing which is very hot in the cryptocurrency space are decentralized autonomous organizations, which are somehow like the equivalent of an anonymous company, or I don't know, it's called in the US, but a company where you own stock. Instead of owning stock, you own something, whatever, tokens, whatever, into this organization. And this organization is not led by a CEO or by a board of directors, but it's held by voting shares. And the people who own shares into a DAO, you can vote with your shares and you can decide what the DAO is going to do. Is it going to invest money here? Is it going to invest money there? And so on. It's a kind of very, let's say, bleeding edge concept which goes much more farther than just a technical point about cryptocurrencies and so on, or blockchain in general. It goes on to some even ideological concepts, so we're gonna just keep it here for now. Some people want to use also blockchain as an immutable proof of voting or government or taking actions when you're interacting with your government or whatever it is. Making sure that, for example, you request something to an organization. It can be, you need a new driver's license, you need new plates for your car, you go to the Department of Motorized Vehicles, and you want to input something, you don't want to wait 6 months to get your car plate, right? So you have here proof that you've been requesting something, it's controlled for good, and you can go. So any questions on the use cases, because there are quite a lot of them. Okay, I think we're anyway tight on time. So a couple of considerations. You should always have a good rationale for jumping into a blockchain project. So you need to think about not reinventing the wheel, but thinking if there is already an existing solution to your problem. Yeah, there's a lot of things that you see in the internet. when you go through various blockchain projects, whether they are cryptocurrency related or not cryptocurrency related, but people seem to, how to say, use one single solution to many things. It doesn't work. It doesn't work in IT. It doesn't necessarily work in storage or in other topics, whether it's cloud, whether it's network virtualization. There are always unique requirements, but there's always a way to sort them out. And the way you should approach a blockchain project, or whatever project, for instance, even before speaking about a blockchain, is to think about the requirements. If you don't put your requirements first, you're going to create something which is going to be very nice, which might turn out being a solution in search of a problem. You should look at limitations. I was talking about those. Transaction speeds requirements and throughput, how many transactions you can do on a blockchain based on the mechanism you're using. Compute power for public permissionless blockchains when you're using proof of work. Yeah, you don't want to turn into the next, you want to turn your blockchain project into the next Bitcoin where you need to buy expensive mining hardware and put your mining devices in China next to a hydroelectric barrier or whatever. And finally, you shouldn't be afraid to explore. You can run POCs, you can try whatever, you can look for advice. But yeah, just take a pragmatic approach to blockchain just like you would with any other project. It certainly has the potential to revolutionize many things. Maybe not now, maybe 5 years from now or 10 years from now. But yeah, just be pragmatic with that, just like you do with everything else. Just don't fall into the trap that blockchain is going to solve all of the miracles. People tend to think that technology is the solution to all of the problems in the world. I think that the problems need to be sorted out at the people level first and then at the process level. Once you've got that sorted out, then you can see whatever technologies works best for you. And with that said, a couple of references here. The links is pretty bad, but I'll try to put that, or we'll try to put the slides somewhere. At least if you look at these documents, if you look at these references, you're going to find them out. There's a draft Analyst standard which is being done around blockchains. It's pretty comprehensive and really good. And there's a document which is created by 2 researchers from EOHK, which is about whether you need a blockchain. Of course, there are more resources like that on the net, and I really encourage you to explore about that. And maybe you'll find whether blockchain makes sense for your organization and your needs or not. And with that, I'd like to thank you so much, and I'm done for today. Questions?
Yeah, one of the things you pointed out about the throughput, I guess 2 days ago, there was a financial conference, and one of the head, I don't know, Deutsche Bank or somebody said that by 2025, most likely bank accounts will go away. And the idea from a technology point of view, the thing that you pointed out is, years ago I used to work for Citicorp. Sybase was the underlying database for the ATMs. So at that point, it was the beginning, no other banks had really any ATMs, but the latency issue. So in your opinion, the blockchain, which would sit as the foundation for accounts going away, what kind of scale are we talking about from your expertise to make that statement? Is that just a bunch of talk or some accuracy around, because you're talking about a scale of all bank accounts, or even if it was 80% of the bank accounts that exist?
I'll try to reply to your question. The core issue of all of the blockchains which exist actually and which are based on Merkle tree structures is the transactional speed. And it can be you can have as much nodes as you want. You still have a dependency on the fact that the nodes, the blocks need to be mined somewhere and validated. So that's why I was alluding to direct acyclic graph. There's an interesting research written by some people. It's called Spectre. Spectre. I'm going to just write it down if there's a place here. If you look up these 2 words on wherever, sorry to get out of the field of the camera. If you put these 2 keywords, Spectre and DAG, or if you put in direct acyclic graph, So if you look that up, then you will find a really interesting research document, a white paper, which was written by researchers of the Jerusalem University. And this document speaks about a new way to somehow validate block in a way more efficient method than what is used by current blockchains. So I'm not saying that this is going to be the ultimate of what you'll see, but with that, you should already get much faster transaction speeds. And that's what all of the financial organizations are probably looking at that. Because even if some people say that blockchain is going to disrupt the financial industry, or that cryptocurrencies will disrupt it, I think that probably what's going to happen is that financial organizations are looking into blockchain right now, and they are trying to understand how they can model that to serve their purposes. And the main challenge they have is how to make a blockchain be as fast, at least as fast as the existing systems in place, right? So, and it goes back to the whole story I was telling about the disintermediation, the settlements between payments between bank A and bank B, and so on. So having a kind of global ledger or multiple ledgers and so on. Hope it helps. Thank you. Right, we're done, right?
Yeah, we're actually done.
Thank you.
Thank you all for being here. I know a lot of you had trouble getting here, or at least with the weather yesterday, were coming in late, or had troubles at home to solve first. But we really want to thank you for being here. We want to thank the sponsors for going the extra length to present here. That's really awesome, and I would like to applaud for that.
Absolutely, and I would even say to go literally the extra mile, because some of them have to disrupt their flights to other locations to make it to New York. Yeah. So thank you all. Thank you.
Thank you.
Very happy to have you here.